this video, I'm going to break down the 12-factor app methodology, a set of principles for building modern, cloud-based applications. We will go through each rule step by step, unpack what it really means in practice, and I will show you how to apply it to your project. My name is Matúš, I'm senior software engineer with more than 7 years of experience, and I've spent past 3 years working on development of cloud-native applications. So let's start with what it actually is. The 12-factor app is a set of best practice for building modern software as a service applications with focus on portability, scalability, and maintainability. It's basically a blueprint on how to write a cloud-native application. Now let's have a look at the 12 principles. To stay organized, I will go over each rule one by one, read its definition, and provide you short explanation highlighting its main benefits. To make this more practical and easier to understand, I will also show how each rule could be applied in a real-world example. A simple library reservation system. This system will consist of a web app interface running on a user's browser, a backend API that processes the user's requests, and a database that stores information about the books and reservations. For better context, think of a typical use case like a user searching for a book title or making a reservation. The rule number 1. One codebase, tracked in version control, many deploys. The explanation of the rule is: whether you are a team or a single developer, put your code into version control system like Git. It will ease up collaboration and provide a single source of truth with traceable history of changes. If there are multiple code bases, it means that you are working on a distributed system where every component is an app that should individually comply with the 12-factor app guidelines. Multiple apps sharing a code is a violation of the rules. The shared code should be factored to a library and treated as a dependency. Such distinguishing between apps define clear ownership and responsibility structure. The single code base does not restrict number of deployments, but oppositely, there can be multiple deployments running on a different versions. Typically dev, testing and prod instances, along with each team member's own instance. This allows parallel work, continuous integration, and etc. In our example app of book reservation system, it would mean having 2 repositories, one for frontend and one for backend. The database would be a managed service, not an app with repo. And in terms of deployments, we could go with dev, testing, and prod. Rule number 2. Dependencies. The definition is: explicitly declare and isolate dependencies. The dependency rule means that your app should explicitly declare all libraries and tools it needs, instead of assuming that they are already installed on the system. Use dependency manager like Maven, pip, or npm to list them and isolate them from the system's global packages. This ensures that your apps runs the same everywhere, on any machine, cloud, or container. It also makes setup easier for new developers and avoids its work on my computer problems. In our example app, the backend could use Maven with dependencies listed in POM XML, and frontend could use package.json file for npm. The rule number 3 is config. The definition says: store configuration in the environment. The configuration rule means that all configurations, such as database URLs, API keys, or credentials, should be stored in environment variables, not in your code. This lets you to use the same code in a different environments, such as test, dev, and prod, just by changing the configuration. Also, it keeps sensitive data out of the version control and makes deployment safer. In our example app, this would mean that we would put database URL, port, database user and password into environment variables. Rule number 4, backing services. The rule definition says treat backing services as attached resources. The backing services rule means that services such as databases, message queues and caches are treated as attached resources that your app connects to via URLs or config, not as a built-in parts of the app. You should be able to swap one service for another, for example swapping Postgres for MySQL without need of changing code. This makes your app more flexible, portable and resilient. In our example app, we would treat database as an attached resource referenced via URL, so it would be swappable without need of a code change. Rule number 5, build, release and run. The definition says strictly separate build, release and run. The explanation is a code base is transformed to a non-development deploy throughout 3 stages. Build stage happens when a new version of code is produced by a developer. In this stage, code and dependencies are transformed to an executable bundle called build. Release stage pairs build with the config, resulting in executable release that is ready to be executed in execution environment. Run stage runs the app in the environment by launching its processes. In the 12-factor app definition, these stages are strictly separated. So for example, a code change cannot happen during a runtime, as there would be no way how to propagate such change back to the build stage. This prevents accidental code or config drift, ensures that releases are repeatable, and allows easy rollbacks. In case of our example reservation system, build would produce static bundle for frontend and a jar for backend. Release would pair build artifacts with config and produce versioned release, and run would start processes of the specified version in the selected environment. Rule number 6, processes. The definition says execute app as one or more stateless processes. The explanation is that app is defined as one or more stateless processes. Any data that needs to persist needs to stay in stateful backing service. This is crucial for preserving possibility of horizontal scaling by adding more processes of the same type and distributing workload across them. Also, it ensures there is no data loss during crashes or restarts. In our example app, backend API would run as a stateless process and database would hold the state. Rule number 7, port binding. The definition is export services via port binding. The rule says that app run its own emptied HTTP server and listen on its TCP port. This way, the app is self-contained and portable, as it does not need any external server to be present on a host. It eases up scalability, as multiple instances can each bind to its own port or can be load balanced. It also makes the app cloud native, as the cloud platforms expects app to bind to a port and then the platform handles the routing. In our example app, backend would listen on HTTP port. Web app static files would be served by simple HTTP server, also bind to a port on local and dev environment, and in prod would be exposed via ingress or load balancer, again routing to a port. Rule number 8, concurrency. The definition is scale out via the process model. The concurrency rule says you should scale your app by running more processes, not by making a single process bigger or multi-threaded. Each process is stateless and independent, so you can easily add or remove instances as needed. This makes your app more scalable, resilient, and easier to to run in the cloud. In case of our example app, we would be able to scale our backend API horizontally by adding more deployments, such as pods in Kubernetes. The workload would be then load balanced. Rule number 9, Disposability. The definition says, maximize robustness with fast startup and graceful shutdown. The explanation is that your app processes should start up quickly and shut down gracefully. Fast startup lets you scale instantly, and graceful shutdown ensures ongoing request finishes instead being cut off. This makes deployments, scaling, and recovery from failures smoother and more reliable. In our example app, it would mean that system would shut down only after finishing an ongoing request. Rule 10, Dev and prod parity. The definition says, keep development, staging, and production as similar as possible. Historically, there were substantial gaps between development and production manifested in the three main areas. Time gap created by code under development being deployed to production in weeks or months from start of its existence. Personnel gap between developer writing a code and ops person deploying it to production. And the tools gap created by different tech stacks used between dev, testing, and production environment. This rule removes the gap by using continuous deployment, keeping developer as closely involved in deployment as possible, and by keeping different environments as similar as possible. This reduces work on my computer problem and helps catch bugs earlier. In our example app, we would use containers to ensure the same environment in dev and in prod. We would keep the same databases in all environments, and we would deploy to prod idly after each merge to main. Rule 11, Logs. The definition says, treat logs as event streams. The logs rule says that your app should write logs to standard output instead of managing log files itself. This way, environment, such as Kubernetes or some log aggregator, collects, stores, and analyzes them. This makes logging simpler, more flexible, and consistent across different environments. In our example app, we would let our backend to log to standard output, and we would use Elasticstack or other solution to handle the logs. Rule number 12, admin processes. The definition says, run admin or maintenance tasks as one-off processes. The admin processes rule means tasks like database migrations, data cleanups, or one-off scripts should be run as separate one-time processes using the same codebase and config as the app. They shouldn't be hidden or done manually on a server. This ensures consistency, repeatability, and avoids surprises in production. In case of our example app, database migration would be done as one-off process using the same config as backend app. Data repair scripts and reporting jobs would run as the ad hoc containers with the same image version as the app. So, that were the 12 rules on how to write cloud-native applications. If you found it helpful, make sure to give it a like and make sure to subscribe if you want to keep learning. Thank you. See you in the next video.